Hey guys, our first day we're going to start out talking about functions, a really important topic in pre-calculus. We're going to start and just simply try to identify the domain and talk about compositions of functions. So we're working through this first couple pages of this packet. Question 1a says to find the domain of this fraction. So now the most important thing about a fraction is the denominator of a fraction can never equal 0. So what we're going to do is we're going to set the denominator equal to 0 to find those bad values. So we're wondering what would make that denominator equal to 0. So in this particular case, this is a quadratic, so we have to factor it. What numbers multiply to negative 6 and add up to negative 1? What about negative 3 and 2? So we set each of these factors equal to 0. 3 and negative 2 are solutions, but be very careful. We want to indicate that all numbers in the world except for 3 and negative 2 are the solutions. So we're going to say x cannot equal 3 and negative 2. And you could check your work by plugging in 3 and plugging in negative 2 one at a time, and you'll see how the denominator is in fact 0, which is a bad thing. You can have 0 in the numerator, but not in the denominator. Next, this is number 1b on your assignment. What if we have a radical in the fraction? First of all, you cannot have a negative under a radical. So 3x minus 4 has to be greater than or equal to 0. But in this particular case, 3x minus 4 in the radical is under or in the denominator of a fraction. So we have to get rid of this little equal sign here and just simply say that 3x minus 4 has to be simply bigger than 0. So to solve an inequality, you build a number line. And on this number line, we're going to put the important or critical numbers. To do that, you change your inequality to an equation, 3x minus 4 equals 0, and you solve. Add 4/3, divide by 3, x equals 4/3. So I'm going to put 4/3 on this number line. So again, 4/3 is important to us. 4/3 is where 3x minus 4 equals 0. And because 3x minus 4 under the radical is in the denominator, this is a bad value. So we're going to put an open circle there. Next, on either side of 4/3, let's see what happens. We're going to pick test values on either side of 4/3 to see what happens. For example, to the left of 4/3, let's test out x equals 0. When you plug 0 in for x, you get 3 times 0 minus 4, which is negative 4. Can you square root negative 4? No. So this section is going to be left unshaded. If I plug in a number bigger than 4/3, like 2, 3 times 2 is 6, minus 4 is 2. Can you square root 2? Yes. It's not very nice, but yes, you can square root it. So the solution for the domain of this question is all values bigger than 4/3. So you can write x is greater than 4/3, or you can use interval notation and use a parenthesis, 4/3 to infinity. Those mean the same thing. Now the last part of today's lesson is Roman numeral 2, or number 2 in our packet, I guess. We're going to find the missing function. So in number 2 in our packet, let's try letter A. Letter A gives you f of x. They are not giving you g of x, and they give you f of g of x. Now what this means is this is a composition. If you plug g of x into f of x, you'll arrive at 5x minus 7. Since they did not give us g of x, we are simply going to take g of x as a variable, plug it in the f of x. So again, think about it. F of g of x needs to equal 5x minus 7. It says so right here. If I take g of x and plug it into f of x, it'll say some mysterious g of x function minus 1 has to equal 5x minus 7. To solve this, you would just simply pretend that g of x is a variable. G of x is 5x minus 6. And you could test that out. If I take 5x minus 6 and plug it into f of x, 5x minus 6 minus 1, of course, is 5x minus 7. So these are pretty short and easy questions. Now, on the other hand, on the next page of the assignment, let's try to find f of x. So let's do letter C. Letter C, number 2. Again, a little bit more challenging. Letter C says that f of x is missing. G of x is known to be x minus 4. And f of g of x is 2x squared minus 4x plus 3. Now think about it. G of x, which is x minus 4, gets plugged into some mysterious f of x function to provide this trinomial. So what we have to do is we have to guess and check or invent a function so that when you plug x minus 4 into it, you get all three of these terms. Now that's a lot to ask. So we're going to do this in steps. The first guess of an f of x function, we'll just focus on the first term of our result. What would you think we should plug x minus 4 into to produce 2x squared? Now, a lot of people initially think 2x. Their brains tell them that this 2x and this x kind of combine to give you 2x squared. But if we try to replace this x with x minus 4, can you see how we're going to just simply have 2x minus 8? This needs to be 2x squared. So that when you try it out, let's do that. Let's try it. Let's do f of g of x and see how we did. I'm going to take the x in our f of x, replace it with g of x. That's what f of g of x says, with our hope being to arrive at this trinomial. So let's see what we get. 2 times x minus 4 times x minus 4. X minus 4 times x minus 4 is x squared minus 8x plus 16. Let's distribute the 2 into this. We arrive at 2x squared minus 16x plus 32. Let's check it out. How did we do? 2x squared, perfect. We got this first term to appear. We have negative 16x though, and we want negative 4x. So in our minds, we're thinking, whoa, that's not good. We are too low by 12x. How do you fix being too low, comparing these x terms by 12x? You go back to the drawing board and you add 12x. So for our second guess, let's let f of x be the 2x squared that worked for the first term. Now, since we were too low by 12x, we're going to add 12x. Let's try and see how that went. So, we're going to replace all the x's with x minus 4. Now, there's no need to really do all this math again. It's sitting right here, so I'm just going to copy that over. 2x squared minus 16x plus 32. But our new addition here, the 12x, that's going to be 12x minus 48. Negative 16x and 12x, of course, will combine to give you negative 4x. And 32 in this new negative 48 is negative 16. Now this is why we didn't adjust both terms at once. We had this 32 here, and if we compared 32 with 3, that would not be a correct thing to do, because now our constant has changed to negative 16. So let's compare. We have 2x squared. We wanted 2x squared. We have negative 4x. We wanted negative 4x. We have negative 16. We want 3. So we are too low by 19. How do you fix that? You simply, for your third and final guess, add 19. So f of x is going to be 2x squared plus 12x. That worked for the first two terms. And too low by 19, we're going to add 19. So that's our final answer. So guys, let me know if you have any questions, and have a great day.